Alright, guys, day 3, video 3. This is the last one, and then we'll have everything we need to kick butt on this CBA. Alright, so starting at number 11, concentrated H2SO4, that's sulfuric acid, is 10 molar concentration. What volume is needed to make 500 milliliters of a 2.2 molar solution? So first thing we should notice here is we've got a change. We're going from 10 molar to 2.2 molar. Well, if there's a change, we know our equation should be M1V1 equals M2V2. So now we need to go back and figure out what we actually have versus what they want to make. So concentrated H2SO4 is 10 molar. That's something that we already have, so it's available in the lab. So we're going to mark that as M1. What volume is needed to make, that's our keywords here, to make 500 milliliters of a 2.2 molar solution? So we don't actually have this yet. It doesn't exist. So this, even though it's the first volume that came up, it's our volume 2 of a 2.2 molar solution. This is going to be M2. We have everything we need to solve this equation. So rewrite this formula. We have 10.0 molar concentration times V1, which is what we're searching for because we didn't have a V1, is equal to M2 times V2, 500 milliliters. And in this case, guys, it is okay to have milliliters as our volume. That's only on the M1V1. If it were M equals moles over liters, it has to be liters, not milliliters. Going to get V2 by itself. So we have 2.2 times 500 divided by 10. That should come out to 110 milliliters. Guys, what that basically means is out of this substance, if we take 110 milliliters of it and add enough water to make it 500 milliliters, that's what our new concentration is. Right, what is the molarity of a mixture that is made up of 76 grams of calcium chloride and 136 milliliters of liquid dihydrogen monoxide? Well, that's just our fun way of saying H2O. So it's a regular concentration question. So M equals moles over liters. We don't have moles and we don't have liters, so we got to convert both of those. 76 grams of calcium chloride. That's going to be CaCl2 because calcium's positive 2, chlorine's negative 1. Got to pop, drop, and swap there. We want moles of CaCl2 versus grams of CaCl2. Calcium. We have 40.08 plus chlorine 35.45 times 2. We end up with a mass of 110.98 grams of calcium chloride. We're going to divide those two because it's on bottom. We end up with 0.6848 moles of calcium chloride. So once we convert this to liters, which is easy, just put the decimal in front of it, 136.136 liters. All we got to do is plug that in now. So concentration is equal to 0.6848 moles over 0.136 liters. M is going to be about 5.04 once we round. Molar concentration of CaCl2. All right, number 13. How many liters of water need to be added to be added? To be added. That's super important for the end of our question. To a solution of 250 milliliters of a 5.3 molar HCl to bring the molarity down to 1.2. So we've got to change. We're adding water to something. This is a dilution. So let's mark what we have. So the solution that we have at the beginning is 250 milliliters. So that's going to be volume 1 with 5.3 concentration. That's M1. And we want to get to 1.2. That is our new concentration. So we're going to find out how much water we have to add to that. Well, we don't really have that in our equation, but we can solve for V2 and then go back and subtract it. So M1, V1 equals M2, V2, M1 was 5.3, M, V1 was 250 milliliters, M2 is 1.2 M, V2 we don't know. Cancels. 5.3 times 250 divided by 1.2. So the second volume, the new volume, is 1,104 milliliters. The problem is that's not what the question is asking for. We've done all the math right, but we need to physically look. How many liters of water need to be added? So we got to subtract here because this is what we started with. This is what we ended with. You're just going to subtract V1 from V2. So V1, or excuse me, V2 minus V1, that's going to give us 1104 minus 250. It's going to give us 854 milliliters. Now, there's one more step here. They're not asking for milliliters, they're asking for liters. If you don't watch out for these simple mistakes, if you would have left it like that, it would not have been complete. So we don't want milliliters, we want liters. So we're going to put that decimal in the front. So 154 liters of H2O. 0.854 liters. All right, number 14. If 280 grams of potassium hydroxide are dissolved in 800 milliliters of water, how many milliliters of water should be added to make the solution have a 1.25 molar concentration? So we've got changes happening here. So we're going to do a M1V1 equals M2V2. So we want to make a 1.25 molar concentration. So That's obviously going to be M2 because it doesn't exist yet. Needs to be added, so we need to know V2, but no, we're going to have another step where we subtract. We have 800 milliliters of water. That's our V1. But we don't have a concentration at the beginning. We know we're solving for V2. We have an M2. We have a V1. We need to get this before we can move on. Luckily, they gave us a mass and a volume, so we can actually calculate that first concentration using our other concentration formula. M equals moles over liters. Well, first problem is that we don't have moles, so let's go ahead and convert this. 280 grams of potassium hydroxide we want that to be in moles. Moles gets a 1. Let's calculate our mass. Potassium, 39.1 plus oxygen, 16 plus hydrogen, 1.01. That gives us a mass of 56.11. We're going to divide that from 280. It's 5.0 moles. Excuse me, molar. I was right, moles. Oops. 5.00 moles of KOH. And we're not quite done yet, so we need to plug that in. We don't want milliliters, we want liters, so put the decimal there. 5.0 divided by 0.8 gives us a concentration of 6.25 molar KOH. And now we finally have our M1. So we can move back to this side. M1, 6.25 times V1, we have 800 milliliters, or you could keep it as 0.8 liters. But the question's asking about milliliters, so you might as well leave it milliliters. Times 800 milliliters is equal to 1.25 M times V2. So we're going to solve for that by getting V2 by itself. .25 times not 0.8, 6.25 times 800 divided by 1.25. V2 is going to be about 25,000 milliliters. Now, again, it's not asking for V2. It's asking how much did we have to add. So we're going to subtract V1 from it. And V2 is going to equal 24,200 milliliters. That's not V2. That's just how much was added. 24,200 milliliters. All right, last question. 250 milliliters of a 1.5 molar solution of NaCl is on hand. But you need some, kind of cross into that, 0.8 molar solution. how many milliliters of 0.8 molar solution can you make? So what we have versus what we want to get to. We have 250 milliliters, volume 1, of a 1.5 molar concentration 1, and we want to get to 0.8 molar. This one's going to be pretty straightforward. So that's M2. M1V1 equals M2V2. 250 milliliters, 1.5 molar is equal to 0.8 molar times V2. So this one, it's not asking about adding, it's just literally asking for V2. So we're just going to divide by 0.8. V2 is going to equal 1.5 times 250 divided by 0.8. 469 milliliters after rounding. All right, guys, that's it for the review. Hope these videos helped out. Let me know if you have any questions for the test, and we'll take care of the sucker tomorrow. Good luck, guys.